A certain company sells fruit juice in cartons. The amount of juice in a carton has a normal distribution with a standard deviation of 3 milliliters. The company claims that the mean amount of juice per carton, mu, is 60 milliliters. A trading inspector has received complaints that the company is overstating the mean amount of juice per carton, and he wishes to investigate this complaint. The trading inspector takes a random sample of 16 cartons and finds that the mean amount of juice per carton is 59.1 milliliters. Using a 5% level of significance and stating your hypothesis clearly, test whether or not there is evidence to uphold this complaint. We have the null hypothesis H0 where mu equals 60, and we have the alternate hypothesis H1 where mu is less than 60. We have x which follows a normal distribution with parameters 60 and 3 squared. Therefore, x bar would follow a normal distribution with parameters 60 and 3 squared over 16. We wish to calculate the probability that x bar is less than 59.1. Let's go to the statistics application, then press the tab key, then the third option for hypothesis test. We have a one sample Z test, and we will select data from variable. We have a one-tailed test. Select the second option. We know that mu is 60. We know that sigma is 3. And we know we have the mean being 59.1. And we have a sample of 16. Executing, we see that the probability that x bar is less than 59.1 is equal to 0.1150, etc. So if we graph this and press tools and the second option to calculate the p-value, we see that p is equal to 0.1150, etc. If we compare this to the 5%, we see that 0.1150, etc. is greater than 5%. Therefore, there is insufficient evidence to reject H0 and conclude that the mean amount of juice in the whole population is less than 60 milliliters. A yogurt manufacturer sells 150 gram pots. The amount of yogurt in a pot is normally distributed with a known standard deviation of 6 grams. The company claims the mean fill, mu, is 150 grams. A consumer group suspects the company is understating the mean. They take a random sample of 36 pots and find the sample mean is 152 grams. Using a 5% level of significance and stating your hypotheses clearly, test whether there is evidence to support the consumer group's suspicion. We have the null hypothesis H0 where mu equals 150, and we have the alternate hypothesis H1 where mu is greater than 150. We have x which follows a normal distribution with parameters 150 and 6 squared, and therefore x bar would follow a normal distribution with parameters 150 and 6 squared over 36. We wish to calculate the probability that x bar is greater than 152. If we go to the statistics application, then press the tab key to set up, then the third option for hypothesis test, we have a one sample Z test. We will select data from variable, and we have a one-tailed test. We know that we have mu being 150, sigma is 6, x bar is 152, n is 36. And if we execute, you see that p is equal to 0.227 etc. And if we graph, press the tools key and calculate p-value, you can see we have the probability that x bar is greater than 152 equals 0.0227, etc. Now, let's compare the 0.0227, etc. with the 5%. We see that 0.0227, etc. is less than 5%. Therefore, there is sufficient evidence to reject H0 and conclude that the true mean fill exceeds 150 grams. The diameters of circular cardboard drink mats produced by a certain machine are normally distributed with a mean of 9 cm and a standard deviation of 0.15 cm. After the machine is serviced, a random sample of 30 mats is selected and their diameters are measured to see if the mean diameter has altered. The mean of the sample was 8.95 cm. Test at the 5% level whether there is significant evidence of a change in the mean diameter of mats produced by the machine. We have the null hypothesis H0 where mu equals 9 and the alternate hypothesis H1 where mu does not equal 9. We have x which is normally distributed with parameters 9 and 0.15 squared, and therefore x bar will be normally distributed with parameters 9 and 0.15 squared over 30. We need to calculate the probability that x bar is less than 8.95. If we go to the statistics application, then setup, then hypothesis test, we have a one sample Z test. Data will be selected from variable. We have a two-tailed test. We have mu being 9, sigma being 0.15, x bar being 8.95, n being 30. You will find p to equal 0.0678, etc. If we graph and then calculate the p-value, we see we have 0.0678, etc. So the probability that x bar is less than 8.95 is equal to 0.067, etc. If we compare the 0.0678, etc. with the 5%, we see that the 0.0678, etc. is greater than 5%. Therefore, there is insufficient evidence to reject H0 and conclude that the mean diameter of mats produced by the machine has changed from 9 cm.